Hello, everyone. My name is Adriana Ángel, and I am the Associate Director of Latin American, Caribbean, and Iberian Studies Program here at the university. It is my pleasure to welcome you to today's LACIS Lunchtime lecture. We are honored to host Dr. Ángel Corraliza, Associate Professor and Ned B. Smith Distinguished Chair of Climatology in the Department of Atmospheric and Oceanic Sciences here at UW-Madison. He is also a MacArthur Fellow, one of the most prestigious recognition in the United States, awarded for exceptional creativity and impact. Please join me in welcoming him for his talk, The Science of Latin America's Weather and Climate, and the history that inspires people from contributing to it. Thank you very much for being here.
Thank you. It is a pleasure to be here talking. So great to have my name properly pronounced. I love it. So, as you mentioned, my name is Ángel, and today I'm going to be talking to you about something that I've been thinking about some time. This is related to my research, but we'll see. I'll give you the introduction and see where my train of thoughts has been moving in the last couple of years here. So I'm going to start talking a little bit about me. Normally, I don't really give my autobiography in a talk. But I feel like I wanted this talk to be like something kind of evolutionary, kind of like seeing where I've been and how my thinking has evolved as my journey and as a scientist has evolved in time. So I'm originally from San Sebastián, Puerto Rico. So San Sebastián is this, the little Google pin there is somewhere in central northwest Puerto Rico. When I was growing up, I grew up, Puerto Rico is a tropical island. So we would have sunsets like this, where, you would get rain, thunderstorms and stuff like that. But normally it's a warm climate, right? It doesn't have like weather like what we're having here today in the afternoon or at any time of the day or in the year, right? So it's a warm climate, very sunny most of the time. That's kind of what I grew up with. And because of that climate and that weather, I grew up really interested in the stuff that happened in my hometown. So for example, like we don't have blizzards, we don't have tornadoes and stuff. Instead, we would have like afternoon thunderstorms, which would occur every afternoon and they would pour a lot of rain. But those thunderstorms usually began as like a train of clouds that would like rush in mid-morning. And so sometimes I would be outdoors chasing some bird or something, and I would notice the clouds coming in. And I thought that was really fascinating. But it wasn't really until Hurricane George struck the island in 1998 that I really got interested in atmospheric science as a career path. And so when this hurricane came in, it caused a lot of damage. And I think before that, I had this idea, maybe from Disney movies or something, that nature was really nurturing and really kind. And then a hurricane came in and destroyed everything, and all of a sudden I realized that that's not how nature is at all, right? And so I wanted to learn why these phenomena could happen and what drove these types of weather patterns that impacted Puerto Rico and the tropics as a whole. So I got really interested in tracking hurricanes. So like if people that are from the Caribbean or know about the Caribbean maybe have seen these weather maps. I don't know if they have them anymore. So as a kid, you would track a hurricane. So you put like a dot wherever a hurricane would be, and then you would like trace the path of the hurricane. So they would be teaching you like to make plots from an early age by using hurricanes as a way for you to like learn these skills, right? So you put the lat long coordinate, and then you would put like the information of the intensity, and then you would like, draw it. It was really, really fun to me, as long as the hurricane wasn't coming close to the island. However, I really started thinking about how I could get to that career, how I can become an atmospheric scientist. And Puerto Rico doesn't really offer a degree in meteorology and atmospheric sciences in general. It offers a minor. So I went to University of Puerto Rico, like shown in the top picture here. And I got my bachelor's in physics with like a few courses in meteorology. I was part of the minor, but I actually didn't finish. I decided that I wanted to graduate and leave for a variety of reasons. But when I was taking those courses, I took a course called Dynamic Meteorology. The textbook for that is shown here. It's the book by James Holton. It's considered a classic book in atmospheric sciences. And it was taught by Professor Luis Bejarano, who fortunately passed away. But I think he was not just my inspiration, but was the inspiration for a whole generation of Puerto Rican scientists in studying meteorology. So Professor Bejarano taught introductory meteorology and the dynamics course. And to me, he was one of the best teachers that we've ever had. However, I'm going to talk a little bit about dynamics. So this dynamics course, even though it was my favorite, it actually focused on mid-latitude meteorology. It did not focus on tropical meteorology, even though I'm studying it in Puerto Rico. And the reason why that happened is because this is the US requirement for the meteorological sequence, right? Like this is what you need to take in order to be part of the National Weather Service in the United States. So even though Puerto Rico is in the tropics, for you to be certified to be a meteorologist, you have to take these courses that are actually focused on mid-latitude weather, all right? So I had very little exposure to tropical meteorology and climate while I was at the University of Puerto Rico, even though my lived experience was tropical meteorology and climate. So I wanted to really study the tropics in a lot more detail. So like I ended up going to a bunch of different places and starting from the University of Washington, where I did get my master's and PhD there, and I did study tropics there, which was interesting. I leave the tropics in order to study the tropics, a point that I'm going to get back to later on, right? And then I did a postdoc at GFDL. So GFDL is one of the NOAA labs, right, that does a lot of extensive studies of different phenomena in the atmosphere and in the ocean. So it's like the fluid dynamics lab, so it's both atmosphere and ocean. And it's actually one of the leading labs in the world for studying and developing also forecasting and climate models. We can talk offline about what it means right now to be at GFDL in this current age. And then I became a professor at the University of Michigan. I was there for 2 years, and then I moved here to the University of Wisconsin in Madison. The last picture here, beautiful Lake Mendota in the bottom there. And so after all this, I can finally call myself an expert in tropical meteorology, like, you know, like moving from place to place, being like a hot potato, moving around here and there. I finally can say that I have a sufficient understanding in tropical weather and climate to give you this talk today, for example. But then a big life-changing event happened last year. I got the call. We just gonna call this the call. So I got a call, and when I picked up the phone, it was the MacArthur Foundation. They had previously emailed me saying that they wanted to talk to me about some consulting stuff, but it turned out that that was just like a ploy for me to actually not ignore the call when they called me. And the call was actually that they were telling me that I was one of the 2022 MacArthur Fellows of last year. And honestly, I had no idea that that was happening. It was a shock to me. Like literally, I was just silent while they were explaining to me the call. And then I had to call my partner, Hannah, and be like, I need to talk to somebody because otherwise I'm going to die. And so this happened. And I got a lot of, it's been an interesting period, right? Because you think that this is going to be like this immense honor, and it is. But a lot of imposterism happened because you're like, why me? You know, there's so many great people in this country, so many great scientists, so many great artists, so many people that are deserving of this award, and then I am the one who gets to get it. So why is that, right? And I have no idea what underwent for me to be selected. You know, that's going to be a mystery probably forever. I'm never going to know. And so I reflected a lot of this, and after some time, I started reflecting and thinking of what I wanted the message that I wanted to give to people be as part of this new platform, right? Like being a fellow now, I've now have this bigger platform, a much bigger audience than what I've ever had before. And so now I'm thinking, so what is it that I want to tell people? So this talk is going to be part of that message that I want to talk to people about. So I'm going to start talking by mentioning what the tropics really are, because it's really easy to forget that the tropics exist, right? Like we're dealing here with a day-to-day weather. We get blizzards, we get all sorts of things. But the tropics are huge. They're a really, really big part of our planet. It's actually half of the area of our world is tropical. And half of the global population lives in the tropics, right? Like these two black dashed lines underline the tropical region of our planet. And you can see that like a lot of highly populated countries are in the tropics. And that includes pretty much the vast majority of Latin America, right? So like this is talk about Latin America weather and climate. You can see in this red box, this is what I would say is that encompasses most of Latin America. You can see that almost all of Latin America is between the two black dashed lines. So Latin America is quintessentially tropical. And so even though so many people live in the tropics, we don't really understand tropical weather and climate as well as we understand weather in the middle latitudes, where the middle latitudes is like essentially this in-between region, between the tropics and the poles is what we call the mid-latitudes. For example, the United States is in the mid-latitudes. That's actually much better understood than the tropics. So most of Latin America is here. So what do we, why have we lagged and what has happened? So the good news is that we have had an expeditious amount of progress in the last 30 years. It's been incredible. We have learned so much about the tropics. And so I'm showing this picture here of a beach with a jigsaw puzzles pieces together, because what I want to talk to you about the scientific part of this talk is just how this jigsaw puzzle has been being put together, especially in the last 30 years. But I also want to give a little bit of historical context because we don't often talk about that history and how that history is deeply tied to all of this scientific progress. So I'm going to start talking about the science here, and I'm going to start with this picture here. Like this is actually like there, when you read more about the history about this quote, like it's actually quite nuanced. But like I think what you talked about with the general population about the idea of standing on the shoulder of giants is this idea that there's these people in the past that have made great contributions to whatever, right? In this case, we're talking about tropical weather and climate, and you're standing on their shoulders, right? So there are these historical pieces and these people that really paved the way. And now the contributions that I am making that have led to me getting this MacArthur Fellowship is partly a result of there being all this insight that all these people in the past have made that have made me able to like go to their research and go to their things and be able to like gain new insights from what their work was. So they paved the way and I'm looking from their shoulders. And that's going to talk a little bit about the science of Latin America's weather and climate and a little bit of that historical context. And these are a lot of things that I've learned from along the way here. So here's an animation. So let's talk about, like we mentioned that almost all Latin America is in the tropics. Half of the global population is in the tropics. Here's an animation of clouds. So these two yellow lines again, mark the separation between tropics and mid-latitudes. The green dashed box is Latin America. And you can see that the weather systems outside of the yellow lines are very different from the weather systems that are inside the yellow lines. So we know you can get, like you do not have to have a PhD in atmospheric science to look at this animation and understand immediately that the processes, the physics of what happens in the tropical latitudes is actually quite distinct from that of the middle and higher latitudes. And that's going to be a major centerpiece of this talk. So when did people start thinking about this deeply? So this is a quote from Riehl in 1954. This is from his book in tropical meteorology, the first scientific book on tropical meteorology that was published. It was published in 1954, 1958. And this paragraph, I think, underscores what they thought at that time about tropical meteorology. So I'm going to read it out loud. Then and there, the question arose, how is it with the other theories insofar as they concern the tropics? In the past, weather and circulation in low latitudes had been regarded as steady, except for the occasional hurricane. The urgent demand of the U.S. Army Air Corps for research in tropical meteorology, which had provided the impetus for founding the institute, belied the old descriptions. Military forces conducting work in the tropics undeniably found that weather, quote unquote, on a serious scale did occur in that part of the world. What brought it on and how could it be predicted? Now, I have a lot of thoughts about this paragraph, and we're going to get back to this towards the end of the talk. But let's talk about like what this inspired and what the science insight was from there on. But like I think you can read this and you can't help but to wonder why this paragraph was written this way in the first place, right? So let's talk about the Institute of Tropical Meteorology. So World War II forced, this is another quote from the University of Hawaii, Thomas Schroeder. He said, the Second World War forced a number of practitioners in the new field of meteorology to spend years in the tropics. It soon became evident that the principles which had applied to the mid-latitudes were dubious at best in the new theater of activity. New theater of activity, the tropics is new, according to the people that were practicing tropical meteorology at the time. So let me tell you a little bit about what the thinking was back then and what they thought the tropics was like. So the mid-latitudes, so here's a picture of a mid-latitude cyclone in the background. So when you think about mid-latitude weather, actually, and the way that we teach it here, for example, at the University of Wisconsin and throughout the United States as a whole, is that in the mid-latitudes, you have these really, really big weather patterns. There, you have the jet stream, you have all these things, and they're moving around. And these big patterns, they're about an order of 1,000 kilometers or bigger. They actually drive temperature, wind, and pressure changes. And these pressure changes are actually the main drivers of cloudiness and precipitation. So the line of causality when you study mid-latitude meteorology is that you have large-scale dynamics, so these continental scale features, and these features then drive precipitation, clouds, and all these weather features. So people thought that maybe the tropics were the same way, that you had these really, really large-scale features that were driving precipitation patterns in the tropics. For example, you have a really large monsoon system, so maybe there's a planetary scale circulation that actually causes the monsoon to occur in the first place. And this actually, this all started to come apart pretty quickly. And this, for example, here's a note from a paper in 1963 by Jules Charny. Jules Charny is actually one of the most important figures in US meteorology. He was pretty much the person who began the impetus and the drive to create numerical weather prediction models. So it was one of the most important features. And he published this paper. I think this was one of his few musings about the tropics. He kind of like thought about it for a little bit, and he published this note here. And he says, okay, so he noted and he did some math, and he found that doing this math, that temperature, density, and pressure patterns in the tropics are actually much weaker than that in the mid-latitudes. So if you look at a weather map of the tropics, you won't notice as much temperature, pressure, and density variability as you see in the mid-latitudes. And that makes a lot of sense, right? We live here in Madison, temperature fluctuates a ton. I lived in Puerto Rico, temperature almost never changes. And so for me, living in the tropics, this is like an obvious statement, but he did it in a mathematically rigorous way, which is actually quite important. And so people thought, based on this insight, that maybe as small as they are, these temperature, pressure, and wind patterns, that they can still drive rainfall and clouds, right? They don't have to be big. Maybe something about the tropics there's something about the tropics that maybe you don't need a lot of wind or anything to cause a lot of rain. It's just ready to rain, right? So you don't need a lot of that for rain to happen. So here's a map. This is actually the Climate Reanalyzer website. So this is for yesterday, right? This is, wait, Sunday. So this is the weather map, the global weather map for Sunday, and this is surface pressure, right? And low pressure is these purple colors, and high pressures are in red. So you can see from this map, because we're in the modern age and we can do this, that pressure patterns in the tropics are much weaker than those of the mid-latitudes, right? You see a lot of colors and gradations of shading in middle and higher latitudes, and in the tropics, it's mostly kind of blue, right? And so, but you don't see that many changes. And the couple of areas that you do see the colors are actually tropical cyclones, which are kind of the exception to the rule, which I'm going to get to a little bit later. But the rest of the tropics does not show a lot of pressure variability. And so people really, really tried. They tried really hard to produce a framework in which you could predict weather patterns in the tropics based on the large-scale dynamics. And none of them really worked. We had all sorts of issues with this, and they were, for the most part, not realistic. So they tried. There was a lot of effort. There were decades of effort, and this just didn't work. So this whole idea of the large-scale dynamics driving rainfall didn't quite pan out. So we needed to rethink what was going on. And so this actually started taking a lot of momentum in the late 80s and early 90s when we started really thinking about models that can actually resolve clouds in the first place. We finally had the technology to simulate a cloud inside of a computer. Before that, we couldn't do that. And this paper from Hell et al. Has an interesting point in the abstract here. It says just a single sentence that really matters here. That says the convection, so convection just means thunderstorms, then evolves into a pattern in which rain falls only within a small part of the domain. The moisture field appears to provide the memory that localizes the convection. And this is going to be a key insight that's going to be important for all the big insights that happen there on. So moisture is just water vapor, right? So all this humidity in the atmosphere appears to provide the memory that localizes the convection. And so what does that mean? So here's a picture, a satellite picture, water vapor. So humidity is shown in colors. These deeper red colors means more moisture, more humidity. And then these gray are just clouds. So these are things being seen in space. We have all this fancy technology from satellites that can observe both the amount of water vapor in the atmosphere and the clouds. And so we see that in the tropics, these clouds tend to be localized. They tend to be focused in regions where the humidity is really high. So if it's dry, you don't see a lot of clouds, but if it's really humid, you see a ton of clouds. And that makes a lot of intuitive sense, but from a physical and mathematical sense, there is actually a lot of nuance behind this. But long story short, it does explain a lot of the rainfall that you see. And so we've now gone to the modern age in which we now understand what is really going on in the tropics. And this is what I think is the more realistic depiction of what tropical weather and climate is. So instead of having like large-scale dynamics and a single arrow towards precipitation, we now have multiple arrows. So it's now a two-way street, right? The precipitation can also drive large-scale dynamics in the tropics. But all of this is also communicating with moist thermodynamics. And when I mean moist thermodynamics, I mean fluctuations in temperature and in humidity. So people in the past didn't really think about humidity all that much because it actually doesn't matter in the mid-latitudes as much as it does in the tropics. It's actually really, really important in the tropics. In the mid-latitudes, it is important, but not as important. You can actually explain a lot in the classroom. You can explain a lot of weather patterns in a classroom setting without actually having to invoke water vapor. You cannot do that in the tropics. So here's an animation. I love this animation. I showed it yesterday at a flash talk in my own department. I don't get tired of this. Again, because you can just watch it endlessly and see the differences between the tropics and the mid-latitudes. Again, Latin America is this rectangle here. So let's focus on Latin America and focus outside north and south of like most of Latin America here. So in the mid-latitudes, you see all these like kind of like rolls and stuff, all these mid-latitude weather systems. That's what brings blizzards and rain and all sorts of things here. But in Latin America, you see that most of it is actually in the tropics. And what you notice here is that if you look at this animation, for example, you see that Colombia, Brazil, Venezuela, you see that you have these red colors. And these red colors indicate a lot of water vapor. It's really humid in these regions. And these white colors are all the thunderstorms, all the clouds. And you can see that in this region, sometimes it doesn't rain, but when it does rain, it's always in these red regions here. So here's the thing. If you look at this, we know that the humidity is really important, but even in close to the humidity, you'll see features, right? You see maybe outside a hurricane forming like in these waves, but you also see thunderstorms that are kind of like moving west. Some of them are moving east. You kind of have to squint. Here's a hurricane over here. And so you see that even within this big envelope of humidity, there are patterns, right? They're a little difficult to discern, but they are actually definitely there. So we've used fancy stuff, math and stuff to like separate what is actually going on in there. And again, you can look at the entire planet, or you can look at Latin America, and you'll see these colors here. So these little lines are actually separating different weather systems. So different named weather systems. So a tropical wave, there's a lot of different tropical waves. So one of them is called the Kelvin wave. I'll get into that one later. The Madden-Julian oscillation is this big blue one over here. And then you have these things called equatorial Rossby waves in the green. You don't even have to know what they are. You just have to know that there's a bunch of different weather systems and that clouds are actually following these weather systems. And if you look at Latin America, you see these red ones coming in through northern South America, and then you see this blue one down there. So you know that these weather patterns affect weather in most of South America and Latin America in general. So you have all these different weather systems, right? And this is very different from the mid-latitudes, where most of the weather here is just a storm system, cold fronts, warm fronts, and they're all associated with these trough and ridges, which are a wave. But that's pretty much all there is. You have all this diversity in the tropics, and that's because of the core features of the tropics, including the amount of humidity that you see. So this is a paper from my time as Adames. Victor is here, so he's the other author of this paper. And we identified all these weather systems that are occurring in the Western Hemisphere. And this circle is actually an observational site in Brazil that was taking observations during 2014, 2015. And you can see all these names here. You don't even have to know what these are. I'm going to tell you what these are in a minute. The whole point is that the blue color is variance. So this is the amount of variability in cloudiness. And you can see that there are 6 panels here. Those are 6 different weather systems. So there are at least 6 different weather systems that contribute to weather variability in Latin America. Like if you just look at South America and Central America here, you will see that there are 6. There are actually more than 6, but that underscores the sheer diversity of weather systems that occur in Latin America that the majority of people don't even know about. Like we know about cold fronts, we know about warm fronts, we know about storm systems, but we don't know about the sheer diversity of weather patterns that occur in the tropics, especially those that impact Latin America, and it impacted me growing up, with the exception of one. So most people do know what an easterly wave is. We know them as tropical waves, and the reason why we know them is because they often develop into tropical cyclones. But we don't know really what an easterly wave is. Sometimes I have this conversation with people, and they start talking about a tropical wave, like, oh, a tropical wave is coming to Puerto Rico, it's going to bring rain. And I ask them, it's like, do you know what a tropical wave is? And they're like, oh, it's this rain, and you're like, yeah. So like people hear tropical waves in the news, but you don't really know what a tropical wave is. So I'm going to tell you what it is. So the trade winds down here are the main wind pattern that blows in the tropics. So the trade winds blow from east to west. The trade winds are not steady. They fluctuate, they undulate. And so these undulations that you see in the trade winds are what we call easterly waves. And they're called easterlies because they come from the east. So they move from east to west. And so the name easterly. So our research our group has actually brought a couple of insights into easterly waves. And so if you look at this bottom panel, you'll notice this Q here. So this Q is actually the humidity, the moisture. So what we found is that in Puerto Rico, for example, North and South America and Central America, we often see periods of really heavy rainfall. And so when you have these periods of heavy rainfall, we have these easterly winds that are coming in. And because of the way that the wind fluctuates, you can often have the wind blowing from the south, and it's tapping on the Amazon basin, and it's just pushing all this moist air from the Amazon rainforest up into the Caribbean and into Central America, into Colombia, Venezuela, and it actually brings a lot of rain. So if you live in this area during the summertime months, this is probably the main driver of rainfall. But most people don't know what this is, right? But that's it. It's actually not that difficult, but you have to really look at weather maps in a very specific way to really know what an easterly wave is. Now, if you're in South America, you might still care about easterly waves, but you have other waves that matter, right? So I said earlier that there are a lot of different waves, and one of them is called the Kelvin wave. So the Kelvin wave, here the colors is anomalies in cloudiness. Red means that clouds are suppressed, and blue means that clouds are enhanced. And the wind here, the dashed colors here are low pressure, high pressure is the solid one, and then the wind direction are these little arrows. So the Kelvin wave is this wave that often comes from the Pacific Ocean and hits the Andes very, very quickly. So it takes like 2 days to move from to the Pacific into the Andes, and then it takes 2 days to cross South America in general. And so you see this wave that's coming from the west, not the east, like easterly waves. They're coming from the opposite direction. And as they're traversing South America, they actually can bring quite a bit of rainfall. Now, notice one thing, that the Kelvin wave is quite big, right? So this is this can just fit in all of South America, right? So we're talking now about a wave that's actually about the size of a continent. And that's not the biggest wave that we have, actually. It's actually one of the biggest ones, but it's not the biggest one. The Meta-Julian oscillation, which I'm not going to cover, is actually the size of the planet. And that's another tropical wave here. And we also have inertial gravity waves. And, I said that there's 4 and 6, so I just don't have enough time to really go into all these waves. And so I'm just going to give you a couple examples just so you can have a little bit of a taste, right? Like a sampler platter of the diversity that we have in the tropics. Another one is the inertial gravity wave. It's the same kind of map. This is again from Maita and Adames, 2023. And you see that the inertial gravity wave kind of looks like the Kelvin wave, but it's like a mini version of it. And the key thing is that you can see these maps and you can imagine that rainfall has increased, cloudiness has increased or decreased. But maybe this one is actually kind of nice because we can actually track it using satellite data. So the way that you can see this is that this thing here is moving towards the west, is actually sipping across and dissipates once it hits the Andes. So the one that you kind of want to look at is this one that's forming here off of South America. This one amplifies once it enters in the Guyana, Brazil region, and then kind of just sips along the Amazon basin very, very quickly. And you can see this blue color with the wind patterns. This blue color corresponds to this stuff here, which are clouds, right? So you got this burst of thunderstorms as the whole thing kind of moves in. And this is actually often associated with what we call tropical squall lines. So if you live here, you kind of know what a squall line is, right? Sometimes it gets really dark and it just pours really quickly, and then the whole thing just moves across. So we have tropical versions of these systems, right? Tropical squall lines are even heavier in their rain, and they often bring thunder and all these kind of things, and they just sip across very, very quickly across the Amazon basin and affecting the countries that are kind of in the vicinity of that area. So that's another type of weather pattern. This is again another from a paper that Victor led in the writing. So it wouldn't be a complete talk about tropical weather and climate if we didn't talk about El Nino, right? So El Nino are changes in the oceanic patterns. So the thing about El Nino that's actually really unique is that it's actually associated with changes in the ocean just outside of Ecuador in Peru. And so when you have an El Nino pattern, the ocean, which tends to be quite cold in that area, suddenly warms. And you would think, like, Angel, what is the concept? Well, it's just the ocean is warming. So it turns out that in the tropics, when this happens, you change the distribution of rainfall. And that drives a ton of weather pattern changes, even outside of the tropics, right? We care about El Nino. Even here in Wisconsin, we are like, oh, it's going to be a La Nina winter. What's going to happen, right? But El Nino is actually a tropical phenomenon. And some of the biggest changes in weather happen in the tropics, and especially in Latin America, because Latin America is right next to the Pacific Ocean where El Nino happens. So if you're in South America, you might notice something like this. So this red colors means a reduction of rainfall, and the blue colors means an increase of rainfall. And there's 3 panels here because El Nino can have a variety of flavors. You can have an El Nino that's in the Central Pacific, so the Central Pacific Ocean warms. You can have one that's just the Eastern Pacific, so just outside of here, warming. And then you have this one, which is one that's been more documented recently, which is the coastal El Nino, which is just specific to the coast of Ecuador and Peru, just a warming that's really confined to the coastal areas here. Now, this one you might not have heard that much in the literature because that one is very, very specific to that region. It doesn't affect global weather patterns. It mostly affects weather patterns in Latin America, especially the area of South America that's adjacent to it. And you will notice here in the red box here that like when you have an eastern or coastal El Nino, it rains a lot in Peru and in Ecuador. Like you have those deep dark blue colors, but the Amazon rainforest actually dries up. So you got this interesting weather pattern in which you get more rain in one region of South America at the expense of another region. Now we have also the area here of Uruguay that also has an increase of rainfall. Now, again, this is very, very specific to Latin America. And again, this is an oceanic phenomenon that's creating an atmospheric response that increases or decreases rainfall. Now, last but not least, we can't have a tropical talk without talking about tropical cyclones. So tropical cyclones, I think, do get a lot of attention. I don't think it's undeserved because their impact and their destructiveness is very, very large. But they're so well documented, and I think most of you have some amount of familiarity with hurricanes that I didn't want to talk a lot about them. I do want to mention, though, that like hurricanes, they're just another part of the tropics, right? So the processes that drive hurricanes are not that different from all the other things that I'm talking to you about. It's just that they get the majority of the attention, right? But that doesn't mean that they're the only phenomenon that happens in the tropics. And in fact, how hurricanes form and how they develop is actually potentially associated with the easterly waves that I mentioned earlier. So understanding how easterly waves grow and form and organize actually can help us understand tropical cycles. And that's, I think, something that the public doesn't necessarily is not necessarily aware about. All right, so I gave you just like essentially like a super fast introduction to tropical weather and climate. I can talk to you about this for hours. And in fact, I could spend an entire semester talking to you about this. There's a tropical meteorology course that I teach in AOS. So you can spend an entire semester learning about this. There's so much to learn about this. And this is a lot of it that I just told you is the last 30 years. So there's just an expeditious amount of knowledge that we've gone through it. But now it's time to go back and think a little bit about the history. And now I'm going to go back to the introduction when I start talking about myself earlier. So this is another line from Rio's book in Tropical Meteorology. It says, then it disappeared. A roar approached as from rain hitting rooftop. When some minutes later they stood on a porch, drenched and shivering, they had realized that cloud tops with temperatures below freezing in the tropics, so like a cloud like this one, it's like pretty shallow cloud, clouds with temperatures below freezing were not needed for the production of heavy rain from the trade cumulus. So these trade cumulus that are very common in the tropics can produce heavy rain, and they're very shallow and they're often well above freezing, right? It's pretty warm. But then this is the key part. There and then the question arose, how is it with the other theories insofar as they concern the tropics? And this is from Herbert Rio, one of the founding fathers of tropical meteorology. He was accounting his first evening at the Institute of Tropical Meteorology, which I withheld the information that this was held in Puerto Rico in 1943. So this actually gives you a lot of questions. It gives me a lot of questions. Like, why did they start questioning everything about the tropics there and then. And that's the key thing about this line. Like there and then the question arose. How is it with the other theories insofar as they concern the tropics? They had not thought about this before. They arrived at the tropics, and as soon as they arrived that first night, everything that they thought they knew about the tropics was thrown into question. So why didn't we question this before? Why did they have to arrive in the tropics and that first night they were questioning that knowledge? And then the second question that I guess, like, who got to ask these questions? Why were these questions being asked at that point? And what were the people that were asking these questions? And the third one is like, why did it take World War II to change this? Why did we have to have World War II for people to go to Puerto Rico and have an institute to study tropical meteorology? That's another question that you ask. And of course, if you've been following this talk, this has been an undercurrent this whole time, right? Like all the quotes that I've been giving you have been hinting at this to some degree. So I actually withheld a lot of important information from this plot early on, and I changed the colors and everything. And what I wanted to show about this talk is that there was a color convention. This is the same version of that plot. And so now you can see what the color bar is. The purple countries are first world countries. The red colors are second world countries, and then the green are third world countries. And the thing that you will notice is that almost all the third world countries are tropical countries, including all of Latin America. So why is it that all the third world countries are tropical countries, where all the first world countries are actually in the mid-Atlantic, say Australia, with being that the only actual exception? So the reality is that we have to think about what actually happened in the tropics. And the reality is that almost all tropical countries were subject to colonialism. Colonialism that was largely driven by first world countries in the middle latitudes came in, and they took all the resources, they brought the seas, they decimated the indigenous populations and the people that were living there, and they left all these third world countries in poverty. And so then these first world countries were enriched. And then because they were enriched, partly because of this colonialism, they had that luxury to ask these questions. The questions that were first being asked about weather in the mid-latitudes, not about weather in the tropics. So tropical countries, on the other hand, were stripped of resources, and they were too poor to conduct this research. And also they were fighting for their lives, right? They ended up fighting for independence. Some of them still don't have, some places haven't gotten independence at all. And so the consequences of that are still felt today, right? Like that is not something that's going to get fixed, like from one day to the next. Almost all these countries are dealing with the aftermath of colonialism up to this day. And so one of the reasons why third world countries are this way is because of exploitation from countries that are in the first world. But it turns out that these are tropical countries and these are not tropical countries. And so like the way that the science of our atmosphere happened is actually deeply tied to colonialism. Now, some people might argue that like, oh, like there's this area that's more favorable to human development and this area is actually in the mid-latitudes. Sure. Believe that there might be something to that, but that doesn't deny the fact that this happened and that people got exploited and people died. And so the aftermath of that is that the dominant way of thinking up to this date is mid-latitude weather thinking. That is what is taught, that is what is enforced, and that is what is required for you to learn. You are not required to learn tropical meteorology. You are not required to learn tropical climate. You are required to learn mid-latitude climate. And that is taught everywhere, even if you live in the tropics. So even if you're in Puerto Rico, you're taught mid-latitude dynamics. If you're in Latin America, you're taught mid-latitude dynamics. You are not taught tropical dynamics. And that, if you're in the US and you want to move to the US, right, and work at the National Weather Service, okay, that makes sense. But if you live in Puerto Rico and you want to just predict weather in Puerto Rico, that doesn't make sense. And in fact, you can go to the textbooks, you look at all these textbooks, these are all mid-latitude meteorology textbooks. There are actually very, very few textbooks on tropical meteorology up to this date. But if you put mid-latitude meteorology or mid-latitude atmospheric dynamics, dozens of books come out. So this also underscores another important event, right? The Institute of Tropical Meteorology was held in Puerto Rico. It was the first major effort to understand the tropics. It was done in Puerto Rico. But this school ended. The scientists that were in that school, they returned. And none of that information was left on the island. They just came back. That knowledge was military knowledge, so it was, not shared. But even after it got disclosed, even though it was no longer when it was public knowledge, that knowledge was not brought back to Puerto Rico. And in fact, Puerto Rico, the vast majority of Puerto Ricans do not know this happened. They do not know that one of the most important schools that actually brought in the insights that has improved their weather that they live on was actually done in their own island. And in fact, I wasn't even taught this. I went to the University of Puerto Rico and I didn't learn about this until I moved to the US. And I was actually a professor at the University of Michigan when they finally learned this. So it took me like 10 years of living in the US for somebody to teach me this. Like I was not taught this in Puerto Rico. But this is an example of parachute science. And this is not unique to tropical meteorology. This is very common in science, where scientists from first world countries go to third world countries and they conduct science experiments, and then they take all that knowledge back and they do not include the people of those regions. They go back and they take everything. I was talking with a Chilean scientist who work with astronomy, and they do the same thing with those observatories in Chile. Like they often do not share. Now there are more efforts for this, but there weren't any in the past century. Latin America has been one of the main victims of this. Like there have been a lot of projects that have been carried out in different regions of Latin America that most people in Latin America have no idea they haven't. People here know, right? If you go and do research in that area, you find out. But the people there deserve to know that. It is actually a point. It improves their lives, but it also can be a point of pride. You know, like I would have felt a lot more proud that Puerto Rico was such an important place for the science that I studied. But that's not a surprise, because weather actually did rise with eugenics. The first weather map was developed by Francis Galton, who is known for starting the eugenics movement. The first weather map was made by the person who initiated the idea of eugenics thinking, right? And you probably all know about eugenics and how devastating it has been to the progress of humanity and how we treat each other. And that's not just Galton. Like eugenics has driven a lot of really horrible things, and a lot of these horrible things are associated with weather. For example, like a lot of like indigenous lands in the US were stripped away with the excuse that we were going to put National Weather Service offices in those regions, or that we were put meteorological stations. People were taken away from there because science needed a place to be studied, you know. And so we took away people, we treated them like animals so we could put some science weather stations. We cannot separate those two things. We cannot talk about this without thinking about all the damage that we had done. And so this leads to one of the big things that if you look at the names of all the people that get recognitions as the leaders in our field, they're all people that often come from Northern Europe, and they come from the US and have some kind of European descendants, right? And that's not a surprise. Like the people that funded weather and climate research also funded eugenics research. That includes the Carnegie Institute, who funded both meteorology and eugenics research, sometimes to the same people that were studying both things at the same time. So maybe it's not a surprise that the people who became the forefathers of our discipline are Björknes, Rossby, people that come from Norway and not people that come from Latin America. Because why? You know, why would these people look at somebody from Latin America? Most of Latin American people are brown. A lot of Latin Americans are black. And even a lot of people that are actually white, but Latin American are considered mutts. They're not considered to be, according to eugenics research, people that are worthy or intelligent enough to conduct this kind of research. So the people who got the money to do it were Europeans. And these European people cared about the weather that impacted them. So it was mid-latitude research. So the implications of Latin America are actually very clear. Latin America was and still is today seen as inferior. And that includes its people, its city, but it's not just the city, the culture, and the people, it's also its weather. Tropical weather has historically been treated as inferior or less interesting than the weather that affects the mid-latitudes. And so and this is one of the key points, that is a key point because that has cost lives, and it's still costing lives because we do not understand tropics as well in the mid-latitudes, which means that forecasts are not as good and people die as a consequence. And the people that get more affected by that are people that live in the tropics, which includes Latin America. So why do we go back to this quote? Like, insofar as they consider tropics, people thought that low latitudes to the tropics were just steady, except for hurricanes. So they just thought that the tropics weren't interesting. It's just sunny all the time. There's no interesting weather. But that is an example of first world bias, right? A lot of these people had never been to the tropics. They just thought that the tropics were this way. So that is a great example of first world bias, right? They just think, oh, clearly that's not as interesting because what's interesting is where I live. And so clearly that's what they thought about the tropics. But you ask somebody in India and they will beg to differ, right? India has a monsoon. It has a really massive weather pattern, really interesting and really impactful for them. Actually, their livelihood depends on the monsoon. And so this mentality, they said that this is an old mentality, but I beg to differ. This is still present today. You go to the supermarket and talk to them about tropical weather. They just think about paradise. They just think about vacation, or they think about hurricanes, because hurricanes also impact first world countries. But the reality is that most people kind of low key don't think that the tropics are that interesting weather-wise. They're just thinking about it as an escape from the inclement weather that affects the mid-latitudes. So it is true that we're standing on the shoulder of giants. I don't, this is a statement people do. And yeah, there are these great intelligent people from the past that have given these insights, but these are people that were selected to be those people. And they're not necessarily representative of all the brilliance that existed. And it is true. But the thinking that led to these people being the leaders of the science is also the reason why we have lost so many lives. So even though we're standing on the shoulder of giants, we are also standing on the mountain of corpses. Millions of people have had to die. They've died so that the tropics became interesting for a select group of people who then became the people who provided those insights. But we don't think about the people that have died. We don't think about all the damage that's caused, because that is uncomfortable for us. We want to celebrate the science because we're scientists, but we cannot disentangle the history from it. So here are my last thoughts, some couple of reflections here. A lot of progress has happened in tropical water and climate science, and we have to celebrate that. Sure, we have to celebrate it. It's something that's improving people's life, regardless of what the history is. And we now understand this subject well enough, in spite of many outstanding questions that I didn't go to talk to you about today, but we can talk about it some other time. But we cannot ignore that history that's led to this progress, or the reason why only some people were able to contribute to it. And the historical and modern treatment of Latin America, because it's not just historical, it's still true today, as well as other tropical countries, because this is not just the story of Latin America. This is the story of pretty much every country in the tropics, the Philippines, India, you name it, Indonesia. I believe that this is one of the greatest human injustices that has ever been seen. And the greatest injustice is the fact that we brought colonialism. We came in, the mid-latitudes came in. I mean, we as in like countries like this country, many European countries came in. They took everything, devastated these populations. And what we see today, that lag in the science and all these perspectives, they're still pervasive today. To me, that is an incredible injustice. And that is one that has cost millions of lives and is still costing lives, because we're still lagging in terms of the science. So that is still costing lives. And the reason why I wanted to bring this talk after getting the MacArthur Fellowship is because we are at a crossroads, because I want people to reflect on this, right? Like what humanity has historically done. We have done many great things, but we've also done some really terrible things. And we need to think about where we are today as people, as a civilization. And we need to really think carefully where we're going, because we may continue to do this, right? This is not necessarily something of the past. I'm talking about the history, but this is necessarily just history. Well, with that, I yield. Thank you all for listening. I hope thank you people for participating. I'm happy to take any questions.
Great talk. Thank you very much. So we have some time for questions. Who wants to start? I'd like to start. Oh, good. Just no, good.
Okay. Well, I was going to say thank you. This was a really fascinating talk. I'm not much of a science person, so I wasn't sure what I was going to get out of this, but I thought it was so fascinating how you were able to connect all this to, like land displacement and, the ramifications of colonialism and tie all of that together. So it was really fascinating.
Thank you.
Are there any, like today now, like really leading Latin American meteorologists or scientists that are kind of trying to pave the way and rewrite this narrative in regard to kind of tropical meteorology?
Short answer, no.
Okay.
Long answer is that I see the new generation, the people that are my age and younger, and you are seeing there are no like necessarily maybe with the exception of one woman, Eugenia Calnay, who was a really important figure in data assimilation and weather forecasting. She passed away recently. She was also one of the first women in the field, and I think she was Argentinian. So she's the only one that immediately comes to mind. There may be a one or two, but like compared to the hundreds of people that have come before, there aren't really that many, But this generation, I I am hopeful because you have people in my group. I have a very diverse group right now. I've learned through Victor. Victor is a brilliant scientist, and I like you see his name coming out on all our papers. This is his work. But like we're going to Lima, and then we're going to Sao Paulo in a couple of weeks, and we're gonna get to see a lot of these emerging scientists there. And from Puerto Rico, there's a generation, from my generation younger, of people who are up and coming, who now have positions here in the U.S. in major research places, universities and research institutions. So I think that is changing generationally. But the old generation, no.
What? Yeah. I just have a question regarding like the curriculum policy. You were talking about how is it all of Western, like the Western Hemisphere is required to study midland tropics, but is that a policy amongst the governments, but only in the Western Hemisphere?
Yeah, it's a policy specifically of the U.S. And so because the U.S. said it first, a lot of countries just follow the template that the U.S. made. And so like it's common in a lot of developed countries because they're just following the template of the U.S. It's not true everywhere. I believe India has a very different curriculum. I don't know what their curriculum is, but like I do believe that most countries have it that way, and also because of history. So even in Latin America, the curriculum is very similar because we rely on textbooks for our classes, and all the textbooks are latitude focused. So like we're kind of like left in, between a rock and a hard place when it comes to that.
And this is kind of like a different question, I guess, more about like, because you talked about how like so much progress has been made in the past 30 years. And I don't know like what work that has been done that is like federally funded. But, like I know like under the current administration and like the push like kind of against science and like climate research, like, and especially like the push against like beyond our borders, like how has that impacted like maybe projects that are going on with like something that you might be doing, or like if there's anyone like within your department or people who are like maybe on federally funded grants or like something to like fund this sort of research, like how have you seen like impacts as of recent?
Devastating. That's the one word I have for it. This is not an opinion. These are just facts. There has been a massive movement towards cutting climate research, tropical weather and climate, mid-latitude. That's all part of that, right? And I don't know how many of you know about this. So one of the main research centers in the U.S. is the National Center for Atmospheric Research. They're going to dismantle. There's been a movement to entirely dismantle that place, and that includes the researchers and the supercomputers. So a lot of a lot of the computing power that we have for climate research is led by that place, and they want to strip that off. So there is a massive movement to dismantle that, but also like no plans to replace things just as satellites. So a lot of our weather prediction relies on satellites that are in space. That's led by NASA. But NASA has been rebudgeted to focus on space research and not on Earth observing research, which is actually surprisingly one of NASA's biggest imperatives, the Earth observing system. Like all these pictures that you see that are very pretty, they're NASA pictures, right? Like they're pictures from satellites that NASA sent. So devastating, and possibly devastating is not sufficient word for it.
You have questions?
Yeah, there's a question from the Zoom. So Juan Carlos Garcia asks, what does the interaction between mid-latitude and tropical weather organizations look like? Are there ways that this gap in research is institutionally reinforced?
That is actually a really profound question. So I separated the mid-latitudes from the tropics, kind of like putting like these lines, but it's actually like not like that at all, right? Like they are dynamically distinct, but that doesn't mean that they interact. And in fact, a lot of important climate, implications are related. So the tropics enforce a massive role in determining our planet's habitability and the energetics. Like we would not be in a habitable planet if it weren't for a lot of the things that are coming out of the tropics to help modulate our planet. So it's not true that they are like separate, right? They're constantly interacting with each other. But and how they interact is actually of profound importance, not just because a lot of tropical weather patterns are often associated with mid-latitude disturbances that come in and kind of excite them, but a lot of mid-latitude weather patterns are associated with tropical ones. El Nino being